The next lecture is about the after what we saw so far. This is a series of lecture about the power plant engineering and the power system engineering. So this video could be 5-10 minutes long, and this is about diesel power plants. So there could be some really good information about to you. There could be some really useful information. So you could consider watching this video for the length. So this is not a substitution for what you could do for exam preparation, but this will give you a good understanding of the subject or some insights to the subject, also something from my knowledge which I'll be adding. So what we saw was about the conventional sources of energy, the non-conventional sources, when we saw about the power plant economics, and diesel power plant is one of the non-conventional or the conventional sources of power plant running from the diesel as a fuel. So again, what we saw, the power utilization, power plant capacity, the load factor, the demand, and how the tariff was calculated, everything. And this is about the diesel power plant. And if you consider the diesel power plant, so if you consider each and every power plant, there would be a prime mover, which will be the source of mechanical energy, which will be rotating the electrical component, which is the alternator. So there is a conversion of mechanical energy to electrical energy, and something has to produce a mechanical energy, and this mechanical energy in this case will be produced from the chemical energy, which will be from the diesel, and it will be produced from the diesel engine. It is the same kind of engines found in the diesel cars or anything like a diesel auto or auto cycles and diesel auto engines, etc. If you have studied that in the mechanical engineering, I might cover or I might make some lectures on that series also if I get some time. But again, seeing that the diesel engine is one of the components, as you can see in the diagram, then the diesel is a working fuel and it will burn in the combustion chamber or the cylinder, and there is a conversion of chemical energy to the mechanical energy. There is a rotating shaft, and this mechanical energy will be converted to the electrical energy from the alternator. So again, these are also known as the internal combustion engines. The diesel engine could also be known as the internal combustion engines. So again, coming to the diagram, as you can see, so there is one of the component is a fuel oil tank, which is the place where the oil will be stored, that is a fuel will be stored, that is a diesel. And then there will be the pump which will be used to pump the fuel from the tank to the engine. So again, diesel engine is an internal combustion engine. So what will be happening in the combustion engine is that the combustion engine is a closed chamber where high pressure environment will be produced. So there will be hot air which will be needed for the combustion, and there will be also fuel which will be needed. So when compressed air at a higher temperature usually, and the fuel is being coming in contact and there is a burning happening, huge amount of energy will be released. So this is how the combustion engines work, and that is a little out of scope to go in detail of the different kinds of combustion engines, like a 2-stroke engine, 4-stroke engine, etc. possible. And but to know that there is a compressor which will increase the pressure of the air, and the compressed air will be supplied to the diesel engine, and then there will be again exhaust gases which will need to be moved out, and then there will be the lubrication process for the engine, which will having a separate cycle. So there will be the oil cooling of the full engine happening. So you will need to keep some of the parts of the engine at a lower temperature. For that, the oil will be circulated also to keep or lubricate the moving parts like the piston, etc., which will be there in the engine. So that would be oil cooled, and there is a oil cooling part, and there is a condenser which will be used to cool the oil as part of the cooling water pump, etc. So coming to the different parts, the first part is a diesel engine. This could be a 2-stroke engine or it could be a 4-stroke engine. Then there is after the engine there is a generator, which would be alternator. It could be even DC or AC. So DC power plants or DC generator are absolute in modern cases, but it might much needed for specific applications or to run specific kind of machinery like a DC motor or DC drives, etc., where you will need to have a DC generator, something to run the DC generator to produce a DC electricity. To if you can supply that to the if you're going to supply that to the DC motor, etc. But again, converters are used for that. So again, it could find some application in some kind of machinery. But the exciters will be DC generator, and there would be there would be again an exciter would be another component. So this would be for the field production of the alternator. So there would be a DC generator which could be needed to needed to produce the field for the alternator if you are doing that for the DC case, or for the alternator if you are having a fixed field. So again, there is a fuel oil tank, as you can see, and there would be a cooling tower or condenser, which, as we discussed, was to cool the oil cooling cycle. So to reduce the temperature of the oil which is being circulated in the engine, so that is bringing the hot oil out, that is observing the heat from the engine, and again you are cooling it and supplying it back, so that again you are getting the cool oil and you are again removing the heat out. So again, there is air compressor which will be used to increase the pressure of the air before it is being supplied to the engine for the combustion purpose. So again, the need of the compressor was to supply the high compressed air. So these were the different components of a diesel power plant. And if you are considering the real scenario, then the diesel power plant will be mostly used, if it is connected to the grid, it will be mostly used to supply the peak load. Suppose there could be a peak load during the period of day, like 1 or 2 hours, during which there is a peak load of 100 kilowatt, etc. So during that time, you could have a standby power plant, which could be a diesel power plant of 100 kilowatt, etc., to supply that peak load. Again, it could be useful to meet the energy requirement for a small, if you're having a small industry, you could have it as a standby generator, etc., in case there is a power outage, etc., and you want to have standby generators, etc., to supply the power. In such cases, you could have diesel generators, etc., which will be supplying the extra power. Also, this could be used to supply power to small villages, etc., where the electrification is difficult, or it is not possible to build or economical to build the high transmission lines, or to have or to connect such kind of villages or electrify such kind of rural areas. It could be used. So there could be multiple possible applications, but what I just said was some of the possible scenarios in which you could use the diesel generators. Again, this is a series of videos and lectures about the electrical power plants, electrical power system, the power plant engineering, etc., and you could find the full playlist of the videos in the description. Also, you could find the other videos related to this, other topics of electrical engineering related to this in the description. If you like this video, please do subscribe. Also do like, comment, and if you have any suggestions, if you want any new videos for any new topics to be covered, you can discuss that or suggest that in the comments, so that I could make that. If you like this video, please do subscribe.